If we look at each subframe that we had seen in the previous slide, and we kind of, here we are looking at a 1 millisecond subframe, and we had said that there are 14 of these OFDM symbols. So you have 1, 2, all the way to 14 OFDM symbols, and we are looking at a 1.4 megahertz channel, and we had said that there are 6 of these resource blocks, each resource blocks being 7 OFDM symbols. The blue part of it is the physical downlink shared channel. So all the way from OFDM symbol number 4 to 14 is where the physical downlink shared channel is, and this is the channel that contains most of the important information, or most of the information that the mobile is actually wanting to receive from the base station. It transmits system information block. We had looked at the master information block, which had the subframe number and what the bandwidth was. That's very little information. There is a lot more information that is needed about this cell, about this base station, who is the operator, what is the identity, whether the mobile is allowed to use. So there are a whole bunch of system information blocks, and they are kind of characterized. You can kind of, they're given names all the way from SIB1 to, I think the latest is SIB 14 or 16 that is present in LTE. The most important SIBs that the mobile needs to decode in order to figure out whether it is allowed to transmit, allowed to even receive information and then transmit information through a process called camping in a cell, are SIB1 to SIB5. So these SIBs are the most important SIBs that the mobile needs to be decoding before it can even request resources from this cell. The other information that is transmitted is something called paging messages, and paging RRC is radio resource control. So paging radio resource control messages, and we will learn about this paging process when we talk about the case that mobiles can go idle when they haven't been transmitting, and if a phone call comes to them, they have to be paged, and that's where this page message is carried for the mobile. In addition to the page message, there are a few other radio control messages that are being sent. So, and those are also provided in the physical downlink shared channel. So these are control messages which are both from the base station and also kind of relayed messages, the NAS messages from the MME, so that they are also encapsulated in the RRC messages and sent down to the mobile. In addition, of course, the most important thing is the real information, the data that the mobile is trying to receive, and that's kind of shown here for mobile number 3. It's present in the this particular resource block, and these two resource blocks are carrying the UE data radio information. You can see that the UE data radio information can be spread out in the downlink in the downlink channel in non-contiguous resource blocks. They have to be at the minimum resource block level, and we will look at what kind of granularity can be there. All the information in the PDSCH in this entire thing can be modulated either with QPSK. That means there are 2 bits in each resource element, so you have 2 bits or 4 or 6 bits. Now that we have looked at the physical downlink shared channel, which contains the main information that the mobile is looking for, we now try to see what is there in the physical downlink control channel, or PDCCH, which are, as we said, in the first 3 symbols, or it can be 1, 2, or 3 symbols based on the operator configuration. So your operator may have configured its downlink channel to carry where the first 3 bits of your subframe are carrying your PDCCH. This PDCCH carries the information which is called the downlink control information, DCI, and this is the most important information which enables a mobile to decode where information in a subframe is present for it. So this DCI is like the Google index. So if you ever want to find out where all the information in the web is, you need to kind of go to Google, and Google will go ahead and tell you where the information is, and that's what this kind of thing carries. It says, hey, UE number 1, your information is in resource block number, if this is 0, 1, 2, 3, 4, 5, your message is in resource block 2, and when the mobile comes in over here, it figures out, hey, the message is actually a paging message. When a UE2 kind of comes in over here, he kind of knows that this paging message is an RRC message. There are three goals of the messages which are here in the PDCCH. The first one is it provides downlink resource allocation for the same subframe, and the resources that are allocated are actually allocated in resource block group, the RBG as it is called, and the resource block group is the minimum number of resource blocks that can be allocated to the UE. For 1.4 megahertz, that minimum is 1, and for 20 megahertz, the minimum resource block group is 4. So you can have at the minimum 4 resource block groups that are allocated to the mobile. The bitmap is used to indicate to the mobile which resource block is allocated to it. So over here, you kind of got that that this was kind of spread over this over in the frequency domain. And this is kind of interesting because in the uplink direction, this kind of a spreading is not allowed. If a resource is provided to a UE to transmit or told to the UE, then they are all contiguous. So you may want to keep this in mind, that this kind of a structure where some part of the information is in resource block number 4 and other part of it is in 0 and 1 is not possible in the uplink direction, and we'll look at the reason why when we look at the uplink direction. Also, in addition to the allocation of the pointers to where the information is, the other information in the DCI is also the uplink resource allocation for mobiles, and this helps the mobile to figure out where it should be able to transmit in the uplink. And it is not this resource allocation is not for the same uplink resource block, but certain resource block out into the future, and that part of it again we will cover when we look at the uplink direction. So no point wasting time trying to understand that. In addition, the other part that is contained in the PDCCH is the transmit power control. So it is telling the mobile whether it should be increasing its transmitted power or reducing its transmit power. So uplink power control information is sent to the mobile in this downlink channel. We also now will look at the modulation that is used for the downlink. The PDCCH is kind of QPSK. This is to make sure that information is decoded well by mobiles, and the downlink control information has a 16-bit CRC, and you were wondering why the heck am I mentioning such a trivial little detail over here. This when we look at the next slide, we'll figure out how that gets used. So now we know that the Google index is present to you in the PDCCH, and your actual information that you are looking for is in your PDSCH, and that's where all the information that you wanted, and the PDCCH is providing a pointer to the information. So how does a mobile know whether this particular this particular downlink control information is for it or for somebody else? And the way it tries to figure that out is trying to look at identity inside these DCI, the downlink control information that is being sent for the mobile. There are three different kinds, or there are a few, I think there are at the end 4 main identities that the mobile tries to figure out. The very first one is its unique identity, which is called the cell radio network temporary identity. So the cell radio network temp identity. So this is the unique identity that the E node B provides to the UE, that the UE uses for communication between the mobile and the network, and we had covered it in one of the previous lectures on the LTE architecture or LTE attach lectures that we had covered. So the CRNTI is present in the messages that are for a particular mobile, and we see this CRNTI number 2, which tells the UE that this message is for you, and CRNTI 3 is having the pointers to where the information for this mobile is. And the way it happens is the 16-bit CRC over here, which is here you have your CRC, will get scrambled with the CRNTI of the mobile. So the mobile kind of looks at this, is able to figure out, the pointer is saying that the information is in the resource block number 5, but it figures out whether the message is for it by descrambling the CRC by its own identity. So it takes a CRC and XORs it with its own CRNTI, and if it matches what that information there is, then it knows that the information for it is the information in this resource block number 5 is actually for UE number 2, and so on and so forth. So each of these mobiles are able to figure out that this DCI information is for them. The other identity that the mobile is looking for is called the paging radio network temporary identity, and which is the same for all mobiles. And so this is kind of the same value, which is FFFE in hex notation. And over here we kind of provide the example that the RNTI was this mobile UE number 3. All mobiles are looking for it, and they kind of look at the paging, and once they kind of come in over here, they figure out whether the paging is for a particular mobile by looking at the content of the page message. So in order to find out that this is actually for UE number 1, all mobiles have the same PRNTI, so they would all kind of look in over here, and then they will find out whether the page message is for it by looking at the unique identity, which is a NAS level identity. So this is an identity which is provided from the MME in the message itself. The other important identity that the mobile starts looking for is called the system information RNTI, so which is more like a broadcast address, and all mobiles have the same broadcast address, which is OXFFFF, and essentially when it looks like a system RNTI, it figures out that there is SIB information in here, and once it comes in here, it is able to read the system information block message. Now, as we said, PRNTI and SIRNTI, the system radio network temporary identities, are the same for all the mobiles, and the page message or the system SIB messages are not present in each and every subframe. So the mobile doesn't keep checking for PRNTI in each and every subframe, but in those subframes where a page message can be present for it, which are also called paging occasions. So there are certain subframes, which are, I think, 0, 5, and 9, if I remember right, which are having pages, and it's only in these subframes that a mobile will look for paging information for it. There are two other identities. I mean, as we keep looking, there seem to be more and more coming out. There are two other identities that are also present in the DCI that a mobile tries to decode, but these are only during the random access procedure, which is the random access RARNTI, which we had mentioned previously during the random access process, and we'll also cover it quickly in one of these slides. And then a temporary CRNTI. So this is kind of the very first time the cell radio network identity is provided to the UE, but before it really becomes that UE's identity during the random access procedure. Okay. In this PDSCH, what kind of information is present in here, and whether it is data information or a paging information or an RRC message is actually determined also by the logical channel ID. So once the mobile kind of comes in over here, this is a MAC packet, and the very first thing in this MAC packet is going to be something called the LCID, so logical channel ID. And if the logical channel ID says that this is equal to 3, for example, it finds out that yes, this is actually a data information for it. Otherwise, if the logical channel ID over here will say that the logical channel ID LCID is equal to 2, for example, then it knows that this is a signaling radio bearer 2. That's what the information here which is present for it. So both based on the identity which is present, it finds out what the information is, or once it has a specific identity, then it goes in and checks the logical channel ID, which also tells the mobile what exactly the information is in the physical channel.